Hello everybody, I'm Marcus Cavada,
Daniel Roy.
and in today's lesson we will be discussing stoichiometry and limiting reactants. Now, what is stoichiometry? Well, by definition, stoichiometry is a quantitative relationship between the amount of reactants used and the amount of products formed. It is based on the laws of conservation of mass. This law will state that the matter will neither be created or destroyed in a chemical reaction. This means when doing your problems, always make sure that your reactants will be equal to the mass of the products. When using balanced equations, remember that the coefficients of the reactants and products can represent the number of atoms as well as the number of moles. Moles do not directly tell us the mass of the reactants, but we can turn those number of moles into grams. Now, discussing what are mole ratios. Well, these can be used to find the coefficients between the balanced chemical equation to write our mole ratios. It is essentially a balance between any number of moles of any two substances in a chemical equation. For example, we have 2H2O2 decomposing to create O2 plus 2H2O. Our mole ratio between H2O2 will be 2 to 1, and our ratio between oxygen and H2O will be 1 to 2. Some important stoichiometric conversions we'll be going over will be mole to mole, mole to mass, and mass to mass. Starting off with our mole to mole conversions. To find this, you must first begin with the balanced equation. After writing the equation, you will need to identify the substance you know and the one you will need to determine. We will then use our mole ratios to determine the substance that you need to find. We will be diving into our first example problem with a vigorous reaction between potassium and water produces hydrogen gas and potassium hydroxide. Our first step will be to write a balanced equation. Now we know that we are reacting potassium with water, which will yield us K plus H2O, and then when combined they will make KOH plus H2. To balance this equation, we will put 2 in front of potassium and KOH to get the same amount, as well as 2 in front of the H2O. Next, we'll be asked to find how many moles of hydrogen are produced if 0.04 moles of potassium are used. Now, to set questions up like this, we will start with our moles known multiplied by the mole ratio. Plugging in what we already know, we have 0.04 moles, which are given to us, multiplied by the mole ratio of 1 H2 over 2 moles of potassium. This will get us 0.02 moles of H2. Also, it is important to remember that the mole ratio should be the moles of the unknown over the moles of the known. Now, for our mole to mass conversions, suppose you know the number of moles of a reactant or product and want to calculate the mass of another product or reactant. To do this, you will do the same way as before by finding the number of moles, and once found the number of moles, use the molar mass to determine the number of grams that were produced. Now, it is very similar from the practice problem we did before, so I ask you to please take a second to pause and do it yourself. In this question, you are asked to find the amount of grams of glucose that are produced when 24 moles of carbon dioxide reacts in excess water. Our first part you will need to solve will be determine the number of moles of glucose produced by the given amount of carbon dioxide. Take a second to pause if you need. Time's up. Moving on. To solve this, we will use the same steps we used before, starting with our known number of moles, which is 24 moles of CO2, multiplied by the mole ratio of 1 to 6, which will give us 4 moles of glucose. The second part of this question will be asking us to convert the number of moles of glucose to grams of glucose by multiplying number of moles by molar mass. Here, it is simply laying out the format of the question. All it asks is for you to plug in the known values. Please take a second to pause and solve for yourself. Moving on, however, to start, just like before, we will start with our known moles, which we got from our last step we solved, and turn it into grams by multiplying it by the molar mass of glucose, which is 180.18. This will get us 721 grams of C6H12O6 in our equation. A second question that I asked for you to solve would be, given the bounce equation for the reaction between hydrogen gas and oxygen gas to form water, how many grams of water can be produced from 5 grams of hydrogen gas, assuming there's excess oxygen gas? Take a second to pause before I continue. Well, moving on. To calculate the moles of H2, we're going to start with the grams of H2 given us by the equation, divided by the molar mass of H2. This will give us 2.475 moles. Now, using the bounce equation, we will multiply the moles of H2 by the mole ratio of H2O to H2. And because this is essentially 1-to-1, we will be left with 2.475 moles of H2O. And lastly, we will need to convert H2O to grams. So we will get the number of moles we got and multiply it by the molar mass of water. This will get us 44.8 grams of H2O. Moving on to mass-to-mass conversions, very similar to the ones we did before, with the first step being to write the balanced chemical equation, then convert the mass of the reactant to moles. After, the mole ratio will be used to determine the number of moles that you're looking for, but then we'll use the molar mass to convert the number of moles of the unknown mass of the unknown. Here is another question I asked for you to solve by yourself, very similar to the last ones. It is, how many grams of NaOH are needed to completely react with 50 grams of H2SO4 to form Na2SO4 and H2O? Your first task will be to write the bounce equation. Please take a second to pause and do it yourself. Moving on, the bounce equation we are given with is NaOH plus H2SO4, which will react together to create Na2SO4 plus 2H2O. In order to balance this, we will put the 2 in front of NaOH and 2H2O to get the same number of oxygen, hydrogen, and Na. Our second step will be to convert grams of sulfuric acid to moles of NaOH. This is where the stoichiometry will come into play. Please take a second to pause and continue. Moving on, just like before, we will get the known grams of H2SO4 and then divide it actually by the molar mass of H2SO4 in order to get the number of moles of H2SO4, which is 0.510, which is what you should have gotten. Then you should have used the moles of H2SO4, then multiplied it by the mole ratio of 2-to-1 in order to get 1.02 moles of NaOH. For part C, we will now need to calculate the mass of NaOH needed. Please take a second and pause. Moving on, from our last part, we got 1.02 moles of NaOH, and since we need to calculate the mass, we will multiply it by the molar mass of NaOH, which will get us 40.8 grams. Overall, we will know that 50 grams of H2SO4 will react completely with 40.8 grams of NaOH, leaving no excess reactants. And here is more independent practice for you to solve and try on your own. This is a little bit tricky since it's now using liters instead. However, it will be the same process. Please take a second to pause and do yourself. And moving on. For this question, if you have solved correctly, you should have gotten 0.125 molarity.
Now on to limiting reactants percent yield. A chemical reaction will continue to proceed until one of its reactants is completely used up. We can then say that that reactant is the limiting reactant. Whatever other reactant that is left over is the excess reactant. We can determine the limiting reactant in a reaction when given the mass of the reactants. In this example, we're given the mass of sodium hydroxide reacting with 60 grams of sulfuric acid. First, we'll write a balanced chemical equation. And since we know that NaOH is going to react with H2SO4, we can determine what the products will look like and balance the equation. Next, we'll convert the mass of the reactants into actual moles of reactants available. To do this, we'll just take the grams that the question has given us. So we'll take the 40 grams of NaOH and divide and multiply it by its molar mass, which will give us 1 mole of NaOH. Then we'll do the same for the sulfuric acid and multiply by its molar mass and get 0.6112 moles of H2SO4. Next, we find the excess reactant using the mole ratios. We'll use the mole ratio for Na2SO4 and NaOH, which is a 1:2 ratio, and we'll get 0.5 moles of Na2SO4. Then we'll use the mole ratio for Na2SO4 and H2SO4 to get 0.612 moles of Na2SO4. We can compare these two. We can compare the moles that we got from each of these equations and determine that NaOH has to be the limiting reactant since it made less Na2SO4 than H2SO4 did. And now we can also find the excess moles of reactants left by subtracting 0.612 moles by subtracting 0.5 moles from 0.612 moles and getting 0.112 moles left over. So we can also multiply the number of moles of the limiting reactant by the mole ratio of the product to the limiting reactant, then multiply the molar mass to calculate the given mass of reactants. So we'll use the mole ratio for Na2SO4 and NaOH to get the moles of Na2SO4, and then we'll multiply by its molar mass to get the mass of our product, which is 71.0 grams of Na2SO4. Now, to calculate percent yield, we have to make a balanced equation and do a mass-to-mass conversion between the known and unknown. And we use the given actual yield to set up the ratio. The actual yield is the amount of product that was actually found in an experiment. And the theoretical yield is the maximum amount of a reactant produced, which we can find from our stoichiometry calculations. The percent yield is the actual yield over the theoretical yield multiplied by 100%. So in this example, we are tasked to, it's asking us to find the percent yield of aspirin when we mix 13.2 grams of salicylic acid with an excess of acetic anhydride and obtain a 5.9 gram of aspirin in some water. So it's given us the actual yield of aspirin, which is 5.9 grams. And notice how it says that there is an excess of acetic anhydride, which means that salicylic acid will be our limiting reactant. So first, we have to write a balanced equation using the using the reactants it's given us, and then we have to calculate the moles of aspirin, and we take the grams of salicylic acid and get the moles. So we'll do this by dividing by its molar mass and getting 0.0956 moles of C7H6O3. Then we take that mole and multiply it by the mole ratio of our products, and we'll get 0.0956 moles of C9H8O4. Then we'll have to calculate the theoretical yield. We'll take our moles of our products and then multiply it by its molar mass, and that'll give us 17.2 grams of C9H8O4. And to calculate the percent yield, we'll take the actual yield given to us by the question and dividing it by our theoretical yield, which we had calculated, and multiplying it by 100%, giving us 34% yield. So some more independent practice. All you have to do for this is just find the mass of each product that can be formed and the mass of the excess reactant that is left over. Make sure to take your time on this and pause it. Alright, time's up. So you should be able to have determined that NH4 NO3 is the limiting reactant and that 18.6 grams of NH4PO3PO4 was created and 31.9 grams of NaNO3 are also produced. And that 29.5 grams of Na3PO4 is left over.
Well, that wraps up our lesson about stoichiometry and limiting reactants. Thank you all for tuning in, and I hope you all have a wonderful day. But also, please remember to remember everything we just told you. Thank you guys. Bye bye.